Hello and welcome in. Mark here, aka the Markster. This is video number 48 in the FreeCAD series. Today I'm going to make an oversized outlet plate. It's a cover that goes over an electrical outlet, and I need one that's going to be just a little bit wider than the traditional standard size. And the reason I need one a little bit wider is there's a little hole in the wall, a little tear out actually, of some of the paneling that looks like kind of a faux bathroom tile, and it just has a little tear there, and I want to try to cover that up with one of these plate covers that's a little bit bigger than the standard size. I actually already made one of these, and you can see the DD object here already has a bunch of variables that I've already defined, and being somewhat lazy, I decided to reuse this list of variables and you'll see what they are as we proceed. Let me show you which version of FreeCAD I'm using. 0.19 200.36. This is on Windows 10. This is one of the development releases, hot off the presses. Alright, so the first thing we'll do is go into part design. Actually, the first thing to do is go into the image workbench. And I want to create a planar image in the 3D space. Because I have an image I've taken of this wall outlet cover. I'm going to put it on XY plane -1 millimeter, just so it's slightly below the sketch, and that way when I sketch with it, it'll be, I can see the sketch. So let's look at the top down view. I put this on a flatbed scanner, and the reason there's this little hex wrench here is when I put it all the way to the top edge of the scanner, it doesn't get the entire image for some reason. So I put this just as a spacer in order to still be able to get a straight image, so it won't be crooked. If I put it just in the middle of the bed, it's really difficult to get it perfectly straight. So that was the reason for the little Allen wrench there. Alright, so I took some measurements with a digital caliper, and the hole diameter is this measurement across. The hole height is 29 millimeters. So let's scale this image using the scale tool here, and it's going to be 29 millimeters. Let me move this if I can. So I'm going to select the first point, try to get right on the edge there. And it's really not critical because I have all the dimensions. And then select the image plane and say OK. And that scales it to the appropriate size. Alright, now let's go to part design, and let's create a sketch on the XY plane. Now I want to move the image and get it where the center of this hole is on the origin. So we can move the image plane. It has a placement property. So it looks like -5.5, and that looks pretty well lined up on the y-axis. Does not have to be perfect. Alright, now let's go back to the sketch. I guess the first thing I'll do is make a little circle to represent. Uh-oh. It accidentally gave me that tangency. So I'm going to delete that constraint. And I'm going to delete that circle. Try it again. If a circle disappears on you, it's too small. Alright. And that tangency automatic constraint got me. Alright, so I'm setting the diameter instead of the radius because I measured it as diameter. And it was one of my variables. That was a small hole diameter. Alright. Now let's put a rectangle around. And I'm going to center this. Let me move this. Alright, I should be able to get to it there. So we center a rectangle around the origin using the symmetry constraint, taking diagonal points and the origin last, and then selecting the symmetry icon, symmetry toolbar icon. And now our rectangle was centered about the origin. And let's set the height on this. And that is what I call plate height. Now I actually made this a little bigger. Let me close this temporarily. So I made it a little bit bigger because I wanted it oversized in both directions slightly. But I added me a little note here. This is a type string list. It's a new property that I added to the DD object, and put myself a little note of what the original width was. So right here, let me set that back to that. So I'm going to click on here, I'm going to hit clear, and then the default height was 112. Nope, default width is 69. Let me put the width in here on this one, and this will be the height. Again, clear this out, and that's going to be 112. So this will be a standard size plate. I don't want it as a formula, not that it really matters. Alright. Now we'll go back to sketch editing. And we've got our height set to 112 now. And our width, we'll do this bottom one. Oops. I had both selected. Let's do the bottom one instead. And this is our plate width. Alright, looks like I'm a little bit off on my scaling. Let me move this down. So now we need these outlet holes. I'm going to add an arc. I'll catch this for the center. Start up here, come down here. I'm not trying to be exact at the moment. do want to catch this center here on the same point. Alright, right click to get out of that. Now add some edges, some line segments. Taking care to catch that coincident constraint. Alright. Now all four of these arcs will be equal to each other, equal in terms of their diameter. And all four of these line segments will be equal. By the way it works, the first one you select becomes kind of the template for the other sizes when you apply that equal constraint. Alright, now let's set the diameter of one of these. And that was, I don't remember exactly what I used, hole diameter. Alright. And we've got 3 degrees of freedom. Where this is at is 1. Now these two have a vertical distance of 10 millimeters. But let me use my variable for that. And that was hole separation, is what I called it. So now we have 2 degrees of freedom. So we need the hole height. And that was hole height. 1 degree of freedom remaining. And that I'm going to set a symmetry. Oops. About the horizontal axis using these 2 points and the edge. So you can have 2 different types of symmetry. One that we used already was the point-to-point symmetry, and this will be 2 points symmetrical about an edge. The order of selection is not important with this type, but it is important with the 3-point type. It can determine from context what you intend when you're using an edge. Alright, that's fully constrained. And close that up. And we're going to pad this sketch. And the amount is what I measured to be about 2.5 millimeters. And I'm calling that pad length. Alright. I'm in wireframe mode somehow. I can go ahead and hide this image plane. Okay, there's a little bit of a counterbore on this circle. So I'm going to add that with a subtractive cone. And that'll be on the XY plane. And I'm just going to say OK. And the radius is the small hole radius. small hole diameter divided by 2. That'll give us the radius. And the large part, radius, what did I call that? Small hole bore diameter is what I called that. Divided by 2, since this is radius, and the height is going to be pad length. We're on the entire distance because I'm gonna add a little bit more support behind there anyway in a moment. So that's the counterbore. Alright, now there's a back slot that's in the back of here. Let me see if I can pull up that other image. You see this little support, extra support back here. I'm going to try to reproduce this. You can't really see it from here, but this tapers in. It's actually a bit of a curve. It gets thinner here and thicker here. I'm not going to worry about these bits here, but I will try to reproduce this draft here. Alright, so let's create another sketch on the XY plane. And I'm going to click this toolbar icon, switches between section and full view, and what this does is it lets us see our sketch kind of through the object that was in front of it. Alright, so I'm going to add a little rectangle here. Set my view straight here. We'll center it. And this height was 10 millimeters. That was the hole separation. And this width, I had a name for it. That was backslot width. See the advantage of this dd.dd. You don't have to remember all these variable names. If you had put this in a spreadsheet without using that little trick, you'd be jumping back and forth, trying to remember what names you use for all these variables. Alright, so that's that. No, I need a circle for the hole. There you caught that constrain again. Come down here to the last circle and hit delete that. Let's try this again. Alright. Small hole diameter, where you at? Okay. And we are fully constrained as evidenced by the lime green color. And we're going to pad this one by pad length. This time we're going to go in the reverse direction. It's going to be the same amount of pad length as the earlier. So that's what we have there. Now let's see if we can manage to flatten this, taper this in. I don't really think it's all that critical, but let's use that draft tool that we used in a couple videos ago. Now notice the draft it's applying in the wrong direction. I want this folding toward the center. So I'm going to apply a neutral plane. It's going to be this plane here. And the pull direction, I think it's this direction. Let's just see what happens. Alright. So now I need to adjust that draft angle. Get a little more draft on there. 70. Let's try 80. Alright, that looks pretty good. Let me try 85 here. Oops, 85 was too much for it. They most likely intersected is what happened. That's why the error there. So let's try 84. Nope, failed again. Let's clear the error and make sure that we don't miss it if it happens again. 83 degrees. Okay, that looks really good. I'm happy with that. Alright, now notice also on that other image, let's see, here we are. We have a little part right here that extends up about 5 millimeters above the plate, and it's kind of tapered out also. Let me pull up the front image again. Let's see, we got it over here. Let me hide the body. Let's look at it from the top. You notice there's a little bit of curvature here. And this is actually flared out like the other piece is. It's flared out similarly on both sides. So I'm going to try to reproduce that using the using this draft tool here again. So we need another sketch. Again on the XY plane, and you could select also here. And again we'll use that. My measurements were for the outside, not the inside, so I'm going all the way outside with this first one. And we'll center that and set our plate width. Notice I didn't try to create an external link to external geometry, which I could have done with that other sketch. I prefer instead, if I have a set of variables defined, just go ahead and use them. Let's see. So this is our plate width. No, I wanted height there, didn't I? Alright, and now we'll have another rectangle inside of this one. And we'll center it also with the origin. So now it's centered. And I'm going to set this width to plate width minus pad length. And the height will be the same thing. Where you at? Plate height. Plate height minus pad length. Okay. And we'll go ahead and pad that one as well. Again in reverse direction. And a header variable for this as well. That was pad length times 2, I think. Yeah, pad length times 2 is what I used. So pad length is basically the thickness of the walls. Alright. And now let's apply these drafts. So I'm going to select these inside faces first. And try to remember how I did it. Alright. And the neutral plane is going to be this face. And the direction, let's try that direction. That's not exactly right. Must have chosen the wrong direction here. Let's see if I can catch that corner. Alright, let's set a different amount here, 10 degrees. Reverse equals false. Okay, I think we're getting a little bit now. Yeah, you see the darkness there? Let's exaggerate that a little bit more. Yeah, so that's 20 degrees there. And let's do the outside faces also. I don't know if you can do both in one draft. I was able to get it to work with doing it separately. Neutral plane will be this one, and the pull direction is one of these corners. Alright, and let's set that at 20. Doesn't look right. And that's definitely not that direction. that edge and see. Okay, let's look down from the front here. So they're both at 20. Let's go to wireframe mode and look at it front on. So that looks pretty good. Alright. I'm happy with that. And I want to add some fillets to round these off. A little artifact there. It's just a rendering artifact. If that happens to you, just click this icon here. Alright, let's try to add some fillets to there. That looks good. What I like about part design fillets is you get this nice little preview. So I think 4mm is probably what I want there. 5 looks even a little better. And I also want to add these internal faces. These are internal edges here. Alright, I'm pretty happy with that. Now my, with these arrows, my plate that I'm making is currently printing. Haven't actually tried it yet, fingers crossed on that. But it was a little wider than this and a little bit taller. But this should be the standard. That'll fit these United States, what we use here in the States, these electrical outlet plates. Mine actually has a light switch oriented in this direction and an outlet at the bottom. So that's going to do it for today. Well, thank you for watching, and as always, have a great day.